Hi everyone, we're going to evaluate the improper integral or state that it diverges. From 0 to 1, we have ln of x divided by square root of x dx. So this is improper integral. It's has an infinite discontinuity at our lower limit of 0. And then we're going from 0 to 1. So we're going to use part 1 of our theorem and write this as a limit. And then we're going to use integration by parts. So I'm going to rewrite this as equal to the limit. I'm going to write t approaches 0 from the right, replace the 0 with t, the lower limit, and go to 1. So we're having ln of x divided by square root of x dx. All right, so let's do our integration by parts. Here's the formula here. So we need a u and a dv. So u is going to equal ln of x, and dv is going to equal dx divided by square root of x. So now we need v and du. So v is going to equal 2 square root of x for this one, and then du is going to be dx divided by x. All right, so now substituting everything in, we're going to evaluate this. So we're going to get the limit as t approaches 0 from the right, and we have, using our integration by parts formula, we're going to get 2 times square root of x ln of x. Okay, so that part is your uv, and we can integrate this from t to 1. And then we have minus, and we have this v. I'm going to bring the 2 out and write the integral as from t to 1 of dx divided by square root of x. Okay, so finally we need to go ahead and integrate this. I'm also going to evaluate this. So I'm going to write this as the limit as t approaches z from the right. All right, so we're going to get, when you substitute in for 1, 1, ln of 1 is 0. So that's going to be 0 times 2. So that's just going to be 0 minus, now substitute in your t, and we're going to get 2 square root of t ln of t. And then we have minus. Now if you take the antiderivative of that, that's going to be 2 square root of x. So I'm going to multiply 2 times 2 and get 4. And then we have square root of x. And then for that, we are evaluating this from t to 1. Let's see. Now, if I can squeeze that in, I'm going to go ahead and squeeze it in here. So let me do that. We have the limit as t approaches 0 from the right. Now, I'm going to write this in. This is going to be negative 2 square root of t ln of t. Now, when you substitute in the 1, you're going to get minus 4. When you substitute in the t, you're going to get, this is minus all of this, so basically it's going to end up being plus 4 square root of t. Because remember, when you're evaluating, it's the 1, f of 1 minus f of t. So the two negatives are going to make a positive. All right. Now, substituting in our 0, the answer to this is going to be equal to negative 4, and it's convergent. Now, you may be asking about this part here as you take this limit here, and we're using L'Hopital's rule, and you get 0 for this. So this is 0. Clearly this is 0 minus 4. So I want to show you really quick L'Hopital's rule for that. So basically we don't need the 2. You can put the 2 in front here. Or I think it was negative 2. So using L'Hopital's rule, we can write this as the limit. We don't really need this negative 2 when you're doing this because we're going to get 0. But basically, you're going to get the limit as t approaches 0 from the right. And we're writing this as ln of t. And I'm going to write this as t to the negative 1/2 power. So now evaluating this with limits, we can write this the limit as t approaches 0 from the right. This is just going to be 1 divided by t, and denominator is going to be negative t to negative 3/2 divided by 2. So if you simplify this, this is going to be the limit as t approaches 0 from the right, and this is negative 2 square root of t. The 2 will come up here, and then when you multiply these two, you're just going to get t to the 1/2 power. And when you plug in the 0, you're going to get 0. So that's why we got 0 for that first part. But our answer is still negative 4, and it is still convergent. Thank you. Have a nice day. Bye-bye.